Okay, in today's Industrial Academy tutorial, I will show you how can we model concentric surfaces and solids using Inventor. Concentric pipes and surfaces are frequently used in chemical industries and other industries. Frequent examples are double pipe heat exchangers, largely used for heat transport in chemical industries. In this video, I will show you we will model concentric pipes, rectangular channels, and helical coils. Let me start with a surface pipe. Here we have opened a previously modeled surface pipe. We will produce a concentric surface pipe using thickness offset tool. Let me start. Click on thickness offset tool. Select surface and select offset. Let me take it 0.5 inches or 0.8 inches. Press OK. Here we can see that a concentric surfaces of pipe shaft has been produced using offset tools. Offset tool will work when we choose surface option. Now if we want to convert it to solids, again click on thickness offset tool and select solids. Select thickness 0.1 inches. It may be outside, inside, or in both directions. Let me take it inside. Here we can see that surface model has been converted to solid model using thickness tool. Again, we will convert internal pipe into solids. Choose surfaces. Output will be solid and select thickness in any direction as required to your process design equipment. Here we can see that it has been converted to a solid pipe. In this way we can convert any surface to concentric surfaces and concentric solids by using thickness offset tool simultaneously. Let me take an example of rectangular channel. Now I have opened a previously modeled rectangular surface channel. We want to produce a concentric surface at desired offset of the same shape as original channel. Again, select surfaces and select Here we have to select individual surfaces. Now select offset dimension. Let we take it 0.6. Inward, outward, or in any direction. Either outward, inward. Let we try again. Due to some input error, it has been stopped. 0.1 inches surfaces. Select surfaces. It's okay. Here we can see that same type of surface has been created at 0.1 inches offset from all sides of the existing shape. Concentric surfaces has been created using offset tool. Now if we want to convert these concentric surfaces to concentric solids, again select thickness tool. Now we will select solid, and both of one which you want to convert to solid. 0.1 inches remains same. If you want to change, you can change it. Inside, outside direction. Select surfaces. All the surfaces have been selected in outward direction. It's okay. Now we can see that surface has been converted to the solid of desired thickness. Similarly, if we want to convert internal surface into solids, we can do it very simple, in a simple way. It's okay. Here you can see that internal concentric surface has been also converted to the solid. If we take sectional view, we can see that has been missed. In this way we can convert any rectangular channel or surface into concentric surfaces, then solids. Which surfaces are selected will be converted to solids of desired thickness. We can choose selective surfaces, not all, according to our design. Let we take an example of helical coil. This is surface model helical coil, and we want to create a concentric coil of desired diameter of the same shape. Let we try. Select offset tool and select surface 0.1 inches. take some time due to the larger size of the helical coil or depending upon your computer hardware. We can see that instead of offset tool we have used thickness tool wrongly. Again we will select thickness tool and select surface instead of solid, select offset and surface. Let me change offset dimension. It's okay. We can see that a concentric helical coil has been produced based on surface. If we want to convert it to pipe coils, concentric pipe coil and concentric solids, again select thickness tool and select solid instead of surface. Solid tool will increase thickness and reduce thickness. Select surface which we want to convert into solid. Let we first take outer coil. That's okay. It will take time due to larger objects and depending upon your computer speed and hardware. Now we can see that outer surface coil has been converted to the solid pipe coil. In similar fashion we can convert, select solid and thickness that you want. Let me take it as 0.1 inches and select surface. Now in this time we will select internal surface. We can change direction in any way. So now you can see that instruction has been execution has been completed and internal surface coil has been converted to the pipe coil, and this is for outer and this is for internal coil. By clicking we can change thickness of both internal and external pipe coils. That will take is 0.2 inches. Okay, it will re-execute. You can change thickness has been increased to 0.2 inches in outward direction. In similar fashion, we can customize both of the helical coils, internal, external. Practically, these concentric coils are very difficult or almost impossible to fabricate. This is for the sake of concept and virtual representations. In similar fashion, we can produce concentric surfaces solids. Now, if we want to see sectional view, we confirm that the pattern is applied to the whole coil. Select any. Go to the View tab. Flip it. You can see that it has been applied to all revolution of the coil in similar fashion and in perfect way. Concentric pipes are simplest heat exchangers. Double pipe heat exchangers are best example of concentric pipe for the heat transport from hot fluid to the cool fluid. In this tutorial I have shown you three types of surfaces. Concentric surfaces are solids and their 3D modeling and various applications at industrial scales and use of thickness offset command in Inventor and its flexibility. Okay, thank you for watching.